Okay, so this problem is in section 1, 2, which is in talking about quadratic functions. So the question says, from each corner of a square piece of sheet metal, remove a square of side 8 inches, turn up the edges to form an open box. If the box is to hold 288 cubic inches, what should be the dimensions of the piece of sheet metal? Again, if that sounded gibberish to you, I would read it again and again and again until it starts making sense. Okay. So I would do the same thing. Okay. Um, all right. So first let's draw a picture because picture helps us a lot, especially in word problems. So, or some kind of organization or visual. So it says from each corner of a square piece of sheet metal. So let's draw that. So we have a square. Let me pause this for a second. Okay, so we have this square piece of sheet metal, and it tells us we need to remove a square, remove a square of side 8 inches. So in each corner here, we're going to have a little square. Okay, a little square in each corner. Again, this is not drawn to scale. Okay, so and so in each corner we are taking a piece here, and it's telling us that this square is 8 by 8. So this is 8 inches by 8 inches. 8 inches by 8 inches, 8 inches by 8 inches, 8 inches by 8 inches. Okay. All right. And it says once we cut that out, we're going to turn up the edges to form an open box. If the box is to hold 288 cubic feet, what should be the dimensions of the piece of sheet metal? Okay. So, um, so in this case, so again, I don't know what the length, the base and the height is, right? I don't know what the length and width is. So this is X. And same thing here, right? Okay. We don't know the length and the width, but that's what we're trying to figure out. All right. So if this whole thing is say is X, so it doesn't matter which one you use, the bottom or the right, because they're the same. Okay. So if that whole length there is X, okay, what's this piece right here going to be? This little piece. It's not little, but anyway, this piece right there. What's this going to be? Everybody agree it's going to be x minus 16, right? Because if the whole thing is x, we're taking 8 on the top, 8 on the bottom. So that'll be x minus 16. Okay? So that piece right there is going to be x minus 16. Okay? So what about this piece then? What's this going to be here? What's that piece? What's this going to be here? It's the same, right? Because this is a square, right? So that means this is also x minus 16. That means this here. All right, so this little piece here. Oh, that was terrible. I'll just say that. Okay. And that one as well, right? So these here are x minus 16. Again, this is a straight line. Okay. All right. So this is what we have so far. And what we want to do is after we cut up the edge, the corners there, we're going to fold it up. Okay. And we're going to have something that looks like, um, anyway, something like that. Okay. So we're going to have this open box. Okay. All right. So how do you find the volume of the box? What's the formula for that? What's the formula for the volume of the box? Perfect. Okay. Length times width times height, right? That's the volume of the box, right? So length times width times the height. Okay, so we're going to derive that from our sheet metal here. We're going to transfer the information we have from the sheet metal and transfer that to the box. Okay, so what's this going to be here? What's the length of that or the width? What is that going to be? Good, right? It's going to be x minus 16, right? Because that's coming from here, right? It's coming from here, that edge there. Okay. So it's going to be x minus 16. Okay. And then what about this here? What's that going to be? Good, right? It's going to be the same thing. Perfect. Okay. So this will be x minus 16. Okay. Then what about the height? What's that going to be? Again, this is not drawn to scale. What's the height going to give us? Not going to be the same. Okay. So when we fold this at the dotted line, that's going to be, when you fold it up on that dotted line, it's going to be 8 as our height. Okay, so that's going to be height 8. Again, this is not drawn to scale. All right. Okay, so now we have all the dimensions that we need, okay, to solve this. So we have our length, right? So here's our length, here's our width. Wow, it made a square, a rectangle. A length, width, and then here's our height. Okay, length, width, and height. So let's go put that information in here. So we have x minus 16 times x minus 16 times it by 8. All right. And what is that equal to? Do we know the volume?
It would be the 288, correct? Because it says the box is to hold 288.
Perfect. That's exactly correct. Okay. So it's to hold 288 cubic inches. And that's the key word here is cubic. Okay. That represents volume. Okay. So, all right. So we put 288 here. All right. Again, this is the hardest part for students is setting it up, setting this up. This is the kind of the kryptonite, okay, for a lot of students is they can't get to this spot here. It's hard for them to look at this diagram, transfer it to a box, and then from the box to the formula, okay? So if you get to this here, that is a big victory, okay? So that's what we need to do. All right, so now what do we do? Well, we're going to rewrite this, okay? So eventually use the square root method to solve this. So we have 288, and then we have x minus 16 twice. So I'm going to rewrite that as x minus 16 squared times 8, okay? And then we're going to divide everything by 8, okay? So 288 divided by 8 is going to give us 36. Then we have x minus 16 squared. Then we're going to take the square root on both sides, right? So this is what we want. This is another checkpoint. We want to get to this part here, okay? So we can use the square root method. So we're going to take the square root on the left and take the square root on the right. So the square root of 36 is going to give us plus or minus 6. Okay. Why are we doing that? Because we have a power of 2. And that power of 2 tells us we should have two possible solutions. Okay. And then so the square and the radical cancel, leaving us with x minus 16 on the right. Okay. So what's going to happen again? This is a quadratic. So that means then we're going to have two separate equations. Okay. So one's going to be 6 is equal to x minus 16. The other one's going to be minus 6 equals x minus 16. Okay. And then we're going to add. So we're going to add 16 here. So that's going to give us 6 plus 16 is 22 is equal to x. And we're going to do exactly the same here. Add 16 on both sides. So that gives us a minus 6 plus 16 is a positive 10 equals x. Okay. Now, which one is not going to work? Which one is not going to work? Okay, everybody agree? It's going to be 10, right? 10 is not going to work. Okay, so this is not going to work. Why? Well, if we plug in 10 here, right, this is our length and width, we have x minus 16. We're saying x is equal to 10. If we put 10 in, there's going to be 10 minus 16, which gives us a minus 6. There's no way we can't get a negative length. Okay, it's not possible unless you're like in another dimension or something. Okay, the upside down world from Stranger Things or something. I don't. All right, so we can't have that. So in this case, we have only one solution, which is 22. Again, what are we trying to figure out? We're trying to figure out what the dimensions are, right? What's the dimensions of the sheet of metal? So that's what we're looking for is what is the dimensions, right? And again, it's a square, so it's going to be the same for the base and the height or the length and the width. All right, so in this case, we're going to have 22 inches by 22 inches. Now you can verify your answer. Another way to do this is verify your answer that you make sure you got it right. So if we plug in, oops. Okay, so if you plug in 22, so 22 minus 16 is going to give us 6, and this is also 6, and then 8. So if we multiply this length times width times height, so 6 times 8, okay, then we would get 288 cubic inches. Right, so again, this is another way to verify your work. All right, so this problem says from each corner of a square piece of sheet metal, remove a square outside 5 feet, turn up the edges to form an open box. If the box is to hold 245 cubic feet, what should be the dimensions of the piece of sheet metal? Okay. Again, this is the same thing as the last one, but just using different numbers. Okay. So here we're taking out 5, right? A square of side of 5 inches, okay, from each corner. Again, I don't know what the base and height are. I just know they're taking 5 inches from each corner. So that means then if this side is X, then this part where I have a question on should be X minus 10. Okay. All right. And then and so that would be X minus 10 for each of these sides here. So when we fold this, it's going to create that box, right? As we had mentioned on the last problem. So we're going to use the formula length times width times height. Okay. And in this case, we know the volume, which is 245. So we're going to put that here. And then the length and the width, well, that's just going to come from our diagram. So the length and width is going to be x minus 10 times x minus 10. All right. Times that by 5. Okay. All right. Again, like as I mentioned before, this part is the hardest part for students to come up with. Okay. So you should have two of the same factors. What the volume is, it's always given to you, and then what the height is. Okay. All right. So when we do this, um, we're gonna rewrite this as 245 equals x minus 10 square times 5. Then we're going to divide both sides by 5. So the 5's cancel. And then 245 divided by 5 is going to give us 49 equals x minus 10 square. Then we're going to take the square root on both sides. So that's going to give us a plus or minus 7. And then the radical is going to go away with the square. Then we're going to have two separate equations. So we're going to have 7 is equal to x minus 10 and negative 7 equals x minus 10. Then we're going to solve. So we're going to add 10 to both sides. So 17 is equal to x. We're going to add 10 to both sides. And 3 is equal to x. All right, so again, it's pretty obvious that one's not going to work because again, if we plug it back in here, okay, it'll be 3 minus 10, which is going to give us a negative 7. So that's not true, okay? So this one only has one real solution, which is x is equal to 17, or 17 by 17, because they want the dimensions. So 17 cubic feet times that by 17 cubic feet. I'm sorry. It's not 17 cubic feet, it's 17 feet. 17 feet. So 17 by 17. Okay. Oops. All right. Any questions on that one? Oh, what is going on? Okay, good. All right. So we're done with that part. And then we're going to dive now into the next section.